Okay, the topic still the same, just Einstein, photoelectric theory. So this one is a series 2. So from here, we need to go through the following for the generating photoelectric current in the photocell circuit. So suppose it's almost the same like before that what we learned about the photo electricity, how they produce the photoelectron. So from here, they're just using the circuit. Now it's a photocell circuit. Okay, you can see the diagram. They sure got one of the cathode and one is an anode. Okay, so that means later the light that will shine to the cathode. After that, they produce an electron. Okay, so from here you see the process. Okay, first one they say the surface of the cathode, there's a negative. Okay, cathode they join with the terminal negative. They must coat with the calcium and you say lithium, either one. Okay, the connected to the negative terminal and the anode. Okay, the anode is connected to the positive terminal, okay, of the battery. Okay, normally we choose the calcium was chosen. Why? Because they got low work function. Low work function means you easy to overcome the work function, then the electron to come out. Low work function means the threshold frequency also become low. So that means when the light just shine, they can overcome the work function. That means the electron can come out, and also they got kinetic energy. So they will move faster, go to the anode. So normally we want to choose the coating on the cathode must be low work function. Okay, so when the light they just hit to the cathode surface, the photoelectron will be released from the cathode surface. So this is a process for the photoelectric effects. Okay, until the electron to come out. So we call it as a photoelectron. The released electron that will attract go where? Go to the anode. Okay, finally the circuit can be complete. Okay, if no electron, that means the circuit is cannot complete. Until the electron to come out, they go to the anode. So that means we call it the whole circuit become complete. If the whole circuit become complete means what? They got current. So from here, they say a small electric current that's detected in a circuit and measured by using a microammeter. Very small. This one is microammeter because the current very, very small. So they're using the ammeter, only using the microammeter. So this one detect the current, we call what name? We call it as a photoelectric current. So the name is almost the same now, just add the word photoelectric. Okay, we got photoelectron, we got photoelectric effects. After that, we got photoelectric current. So this one is a process how to produce a photoelectric current. Important, you need to over the work function. Okay, now we compare calcium and lithium. What's the difference? Okay, the connection is the connecting also is the same. Okay, just one they code by the calcium, another one they're using the lithium. Okay, calcium, now we're going to see the first part. Work function for the calcium is how many? 2.14 electrical potential energy. Okay, another one, the lithium is 2.5. So that means the calcium become lower a bit. Lower a bit means when the light just shine, they're easy to overcome. Overcome the work function, then they come out. So lithium high a bit lah. When they high a bit, that means the photoelectron you want to, the photo light you want to shine, go there. The photo energy, you must stronger a bit to overcome the work function of the lithium. Okay, let's see the threshold frequency. Work function increasing, threshold frequency always continue to increase. Now you see the threshold frequency must be 5.16 power of 14 hertz. So that means you need to overcome this one frequency. So for the lithium, high a bit, 6.03. So that means the photon energy must be high enough to overcome the work function and also the threshold frequency to let the electron to come out. So the maximum, okay, wavelength and frequency is the terbalik one. When I say the frequency is low, that means your wavelength must be high enough. So from this one situation, I want the electron to come out, the frequency must be low, but the wavelength sure is a longer one. So you can compare, the wavelength produced by the photoelectric current is 579. So 579 is to the lithium. The wavelength is 496. Okay, So the maximum wavelength to produce a photoelectric current is a 496. The wavelength becomes shorter, okay? But the threshold frequency is a higher, okay? So remember, you just go to find out the work function. You want electron to come out faster, work function must be lower. Okay, another one, your threshold frequency must be lower, but the lambda is higher than the another one. So from here, you need to know what is the relationship between the frequency and also the wavelength. Okay, so from here, we can say the conclusion. The higher the work function, the shorter the maximum wavelength required to produce a photoelectric current. So that means the work function and also the wavelength also is inversely proportional. Okay, as the light intensity increases, so the electric current in the photoelectric circuit also will be increased. If the temperature keep increasing or the light intensity increase, so that means you find it, the photoelectric current also will be increasing. Okay, so that means more light to shine. Okay, you find it, the electric current also faster to be produced. Okay, so this one is another option to make the current increases in the circuit. Okay, so from here, remember work function. After that, frequency, threshold frequency. And the last one should be the wavelength. Okay, after finish about the photoelectric, so we go through some application. Okay, photoelectric effects, where we use it. Okay, first one, you can see this one's a solar cell. Okay, LED lamp, okay, along the route, which are powered by the solar cell, and the energy efficient and also environmentally friendly. That means they do not using any power supply. They're just using the original, the renewable energy. Then after that, to produce the light energy. So from here, they say in the daylight, okay, you can see this one, every street lamp also got the solar system. So from here, you can see the photoelectric effect of the solar cell enable the electrical energy to be stored in the battery. So that means early morning, we store the energy, okay, for the photoelectric effect. They're from where? From the sunlight. Okay, from the sunlight, they shine to the surface of the solar cell. After that, they will absorb. And so from here at the night, the LED will be light up. Okay, be light up with the power from the battery. So that means the solar cell, they will keep the energy. The energy come from where? Come from the sunlight. Okay, so through the photoelectric also, the process also using photoelectric, but during the morning, okay, during the day, they will store. So that means inside they sure got calcium, or you say lithium. They will keep it. Okay, after that, finally, they will restore, release, come out during the night. So this one is the first one for application for the photoelectric effects. Okay, number two, they show about this one of the biggest solar power plants. Okay, where's it located? There's a non-complex solar power plant located at the Sahara Desert. Okay, so there's a world largest, okay, largest of the concentrated solar power plant. You can see the whole location, all is a solar system. So from here, they say this one station they're expected to be complete. Okay, 2020 actually finished already lah. Is can able to producing the 580 megawatt. Okay, 580 megawatt power of 6 capacity for use by 1 million of the resident. Okay, for this all solar system. Okay, another application they're using for the automatic door. This one is a detector for the automatic door. So the light detector automatic door, the system they uses for the infrared light beam. They're using infrared light beam. And the electrical component, we call it as a photocell. Okay, infrared and also photocell have a safety features. So when the light just hit the photocell, okay, when the light hit the photocell, electron release. Okay, electron release due to the photoelectric effects and produce a detector electric current. Important, they must have the current. Okay, the current how to come? It depends for the light to shine to the photocell. After that, they produce an electron, then got current. So from here, you can see the situations. When don't have a passenger, you can say the customer, lah, okay, a person, they just go through the door. So that means when they just the light blocked by a person, when you just walk, the infrared, they're blocking by the person. So you can find the electric current that will interrupt. Suddenly the current cannot go already because you're blocking. After that, they're automatic to be open. So this one, it depends, but the area is very small. You can see the red color, this part. The area only this part. Maybe sometimes you are waiting person, you stand at the side. So you can see the door keep open, keep closing, keep open, keep closing. Like this. Because they censor the area. So they don't care you go through the door or you just stand there. They also censor got person. Then after that, they alert, they will automatic to open. Okay, so this is one of the application for the photoelectric effect. Okay, then we go to third one. Okay, the third one is the image sensor, is a main component for the high resolution camera. Okay, this one also one of the sensor. Okay, this one component they use to convert the light, okay, light into the electrical signal. So from here, they will zoom. After that, snap the photo, is it? After that, they produce the light. So this one light, they will change, become the electrical signal. After that, they can process the form, become digital image. So this one for the person, they are more got professional for the camera, they how to use it, how to change, become the objective, one of the lenses that will more clear about this one sensor. How they go to make it become high resolutions. Then when you just capture the image, there's more sharp and more clear. Okay, so this one's a different for the sensor. That means they get the different of the images. So they convert the light. Maybe you capture the light is more. After that, they convert, become electrical signal. They will be more high resolutions. So depends on this one is a one, just like the one glass, one pieces of the glass. So this one is an image sensor component. Okay, they're just in front of the lenses. Okay, in front of the lenses of the camera. Okay, and the last one should be photoelectric effects. There is a ISS. Okay, the operation of the ISS, International Space Station. Okay, that depends on the source of the electrical energy generated from the solar panel. You can see the solar panel, okay, together with the International Space Station. So this one, ISS got 16 wings. You count lah. I count here got 14. Then after that got add 2 more in front. Then they got 60 wings of the solar panel. And every wings they measure, they got 35, multiply 12. Then after that, 8,000 solar cell. Okay, inside got solar cell. Then after that, this one panel can able to generate 84 to 120 kilowatt of the electricity. So that means where they get the electricity, they get from the sunlight. Okay, from the sunlight, because they got solar panel, so they can absorb, they can store the energy. So that means inside they can store the energy, generate electricity 84 until 120 kilowatts. Okay, so this all is related with your photoelectric lah. Important, got light to shine. After that, you go to release the electron. After that, to generate the current. So from the solar panel, they keep the electron, keep the energy first. Then after that, they will release. So important is the first part, shine. Then after that, keep electron. Or you say the electron release. At the same time, they will release the electron. Okay, but the solar, they will keep first lah. When you just want to use, then you release. Okay, so this one is a what for the photoelectric effects application. Okay, so I want to continue for the yesterday. We not yet finished about the part for the calculations. Okay, so for the photoelectric 7.3, there's not much about the calculations. Okay, important, they're talking about the photocell circuit, how they produce a photoelectric current. So, and also the application. So from here, this one, I want to continue for the last time. We not yet finished for the exercise for example question. Okay, let's see this one. The student, please prepare your calculator. Okay, what is the maximum kinetic energy? Okay, they're talking about maximum kinetic energy. Okay, they ask you maximum kinetic energy of the photoelectron emit when the light frequency. Okay, they say the frequency is shown on the metal surface with the work function. Okay, then they give you the Planck constant. So we're going to see info. What is the important info? First, we know frequency. Number two, we know the work function. And number three, we know the Planck constant. So they do know what's a K max. Okay, remember the K max formula? There's a Q, K-E-W. So from here, we just show, okay, K max is a E minus W. Okay, from here, the E, the question never provided. Okay, don't misunderstand. This one, Joule function, work function is a W, not E. Okay, E is a HF. This one is a work function. Don't misunderstand. So from here, we become H, Planck constant multiplied with the frequency, because the question provided the frequency. So from here, I want the answer from the student. What is the K max now? Okay, kinetic energy maximum. Okay, give me the answer, please. Okay, just press your calculator for the, okay, Jaya, give me 1.104 power of negative 20. Okay, we're going to show the calculations. Remember, when you press the calculator, 6.63 power negative 34, 5.34 power of 14, equal first. Don't straightforward go minus. Put equal first. After that, take your answer, go to minus W. Okay, so the final answer, 1.104 power of the 10, negative 20. Okay, power of negative 20. Remember the unit is a joule. Okay, so from here, so you're going to check. This one normally is, you know how to apply, just the problem is calculations. You press your calculator, got a little bit mistake. So the final answer all wrong already. Okay, remember the skill how to press your calculator. Okay, then we go to the next part, example 2. Okay, they ask you what is the work function. Okay, they want to find W of the metal if, okay, you can see the word threshold frequency. They told you threshold. They never say normal frequency, they said threshold. So you must remember this one is a F node. Okay, F node is provided. Then they give you the Planck. Okay, after that, you need to find the work function. So we write the info first. Okay, threshold frequency is 9.85 power of 14. Okay, then after that, the Planck constant, okay, they want to find is a work function. Okay, so from here, what situation we call it as a threshold frequency? Okay, you remember the graph? Okay, the graph, okay, like this one. Then this part is a threshold frequency. Okay, when the situation is a K max, okay, versus frequency. So that means when you get threshold frequency, means the K max is how many? K max is a 0, then you're using threshold. If the K max is not 0, you cannot using threshold. You still use. Okay, so for this one situation, we know kinetic energy is a 0. Okay, kinetic energy is a 0. Okay, recall back just now the formula Q, K-E-W. So now the K max no more already. Straightforward, your formula is a W equal HFO. So that means just now the K max equal E minus W. So this one becomes 0 already. So your answer is a E minus W. Okay, so from here, E is how many? E we normally take HF, is it? Okay, for this one situation, there's a threshold frequency minus W. So from here, W equal HFO. Okay, so remember, when you read the question, must be careful. When you just say threshold frequency, you must be careful. This one situation, the kinetic energy becomes 0. Okay, so from here, I want the student to give me the answer for W is how many? Okay, 6.531 power of negative 19. Okay, we go to show. Okay, I just multiply only. I take the H. Okay, multiply with the FO. Okay, so after that I get it 6.531 power of, yes, correct, Sharon. Okay, negative 90 joule. Remember the joule. So this one is how to find the work functions when they just mentioned there's a threshold. Yeah, Khatija also correct. Okay, so this one is example 2. Then we go through to the next part. Okay, example 3. What is the maximum kinetic energy? They want to find the maximum kinetic energy of the photoelectron. Okay, emit when the monochromatic light with the wavelength. Now this one situation got wavelength. Okay, they're shown on the metal with the work function 1 eV. Okay, 1 eV. Yeah, 1 eV means later you need to convert become joule lah. Okay, so we see the question give you some more HC. They give you HC. Okay, so HC actually you need to using the HC over lambda. This one is the formula for the photo energy. This one. Okay, so that means later you need to using the HC. Go through the info first. Okay, the HC is provided. Okay, W is a 1 eV. Then after that, they give you the lambda. So that means later this one and nanometer, you need to cancel by using the lambda lah. Okay, you need to cancel. Then after that, we can get the unit with the EV. Then we can do the calculations. Okay, so they want to find Kmax. So we just show the formula for the Kmax. Okay, this one we just solve first. We want to get the energy first. So from here, I just apply E equal HC over lambda. So HC I know already, 1.243 power 3. So over the lambda. So later you can see the nanometer, they can, each other can cancel. So I just apply, so you can see the situation like this. So from here, the HC over the lambda. So nanometer no more. So what is your energy now? The energy now is a 2.07 electrical potential energy. Okay, you can refer the question. They never provide E is how many. They never say electron is how many unit. Okay, how many joule? They never mention. So that means we no need to convert lah. Our unit only in EV. Okay, electrical potential energy. But now the question, they want to find kinetic. They want to find kinetic. So from here, we need to find another situation for the kinetic. Only the one formula from the 7.3. There's a Kmax equal E minus W. So from here, E we get already lah. This one is an E just now, I get it. So I don't know what is a Kmax. So from here, I just apply. Okay. So 2.07 EV minus 1 EV. Okay. 1 EV is provided from the question. There's a work functions. So from here, your kinetic energy is how many? Kinetic energy is 1.07 EV. Okay. We don't have any unit to change become the joule because the question never provided the electron is how many. Okay. So from here, Kmax only can write 1.07. EV also is one of the unit of the energy. Okay, so this one is a example 3. Okay, so I go to the next part. Oh, next part is finished already. Okay, so just from here, thank you everyone.